Again, good morning. I'd like to take a minute to introduce myself. My name is Alex Miller, and I am part of the 21CS customer success team here at 21CS for ZOS. My job is to partner alongside clients to ensure that our solutions align with their goals and initiatives, ultimately providing support from the initial conversation to the ongoing sales and support relationship, all the way till the end of the product usage or the end of the contract duration. Today, we're going to be diving into TRANSVERSEⁿ, as you all know. It is our latest software solution. This provides end-to-end non-disruptive data migration, and I am super excited to be joined by our technical expert, Ken Strickland, who is going to lead the discussion in just a few minutes, share best practices, and get into the technical aspects of the tool. Throughout the course of this webinar, our Q&A box will remain open for any and all questions or comments that may pop up during this presentation. We will address as many as we can. If we can during the webinar, we will, but due to time constraints, we may leave as many as we can till the end. And if for anything we cannot get to, we will absolutely follow up with each and every one of you that poses a question after the presentation. So thank you so much again for taking part of your day to come join us. Let's get started. I'm going to go ahead and hand this over to Ken Strickland, who's going to walk us through the webinar and the tool itself.
Thank you, Alex. My name is Ken Strickland, and I provide technical sales and implementation support for TRANSVERSEⁿ. I've been in the industry since 1978, and I've been doing data migrations probably for 35 years. So today we're going to talk about TRANSVERSEⁿ. It's a ZOS non-disruptive data migration, and it will allow you to automatically and dynamically swap DASD volumes from source to target. The typical migration planning effort includes, first, you need to analyze your current environment. You need to know what infrastructure you have available to you for the data migration. You need to know how many data volumes you have that you're going to migrate. You need to understand the usage patterns and the application dependencies. And then you also need to make sure you understand the performance requirements, because as you do data migrations, this will allow you to do the actual copy while the applications are active and no downtime is required. Once you have a good understanding of your environment, you have to set up the target environment. This is typically new storage that comes in for a tech refresh. You have to go in and initialize the volumes to start the process, and then you have to determine the source and the target migration pairings or volume pairings. Once you get that, then you have to determine whether you're going to do an online or offline migration. An online migration means everything is up and available, production environment. You do an automatic swap, there's no impact to the end user. Offline migration means that you could potentially want to move some of your special volumes, like your IPO volume, your catalog volumes, your XCF coupling facility volumes, from a system like a floor system. So you would take the production system down, run the migration from a floor system. And then you have to actually execute the migration. You have to set up the jobs, you have to identify the volume list, you have to perform the migration, and then you have to monitor the migration to make sure there's no issues. And once that's complete, you have to verify that your migration is complete. With that said, what we've done is we've had a major enhancement to the 6.1 release, which is called the Migration Planning Assistant. This is not available at the lower levels. It's only available at 6.1, which has been GA, which is the current GA product. The way it works is we provide an automated and intelligent migration planning solution for you. It's very flexible, but the first process is to do a system and storage discovery, meaning we have to understand what the environment is that we're working from. We have to understand the volume capacities. We have to understand how many source and target volumes you have. So we have to first run a discovery program to identify this environment. And we understand that this environment can be very complex, and it can have multiple volumes that are online and offline to different LPARs within your sysplex. So that's the first step, is to do the discovery. And then what we do is we automate the JCL for you to run this migration. This is the major enhancement, and in my opinion, it's a game changer as to how this process works for small to medium installations, because this process requires putting together many different jobs and making sure that they're coordinated, associated when you do the synchronization at a certain point. So what you have here is we have an automated process that's repeatable and can be used to generate the JCL for your migration. We have a global controller. This means that we can synchronize multiple sessions at once and not have to go to each session specifically and do the prompt. The way it works is that you have master and agent jobs running. You have a master job that does your actual data copy, and you have agent jobs for every system that has access to that volume you're copying. So we have the option to automate the synchronization and swap activities with one command. And then we also provide advanced reporting. Advanced reporting is individual reports for each individual session. We also have the ability to interface with any type email facility you may have to issue emails for status reports on an interim basis. So you can, whatever interval that you want to do the status reports, whether it be a minute, an hour, or whatever, you can issue those emails automatically if you have a JCL-based email facility available. And then we identify volumes that may have failed during the migration, so you can actually do a retry, and we build that retry JCL for you automatically. And then we have provide a migration project summary, meaning that we will give you a project summary of how many volumes were migrated, if they were successful, and how long it took to do that. Now, the way this all works and the way it's set up, it's part of your install of your product. So when you install Transverse 6.1, it is part of your product install. There's no additional installation or work that you have to do to enable this process. It includes a member called LTD plan, which will be distributed in your sample lab dataset. So you have a software install, you have a sample lab dataset, and you have a member called LTD plan. What that does is the LTD plan generates all of the datasets that you need and all of the members to allocate syscoms and other pieces that you need for the migration. And I'm going to go into an exact demo and walk you through each of these processes after this slide. But once you have allocated your working data sets, you have a member called LTD Discovery. This is the discovery program that runs on your Sysplex. Typically, we've seen customers do a migration and they have to run a decollect type process on every LPAR within the Sysplex. This is one of the changes that we've implemented to where you only have to run it on one system in the Sysplex, and we get all that information. And then we do a job or a program called LTD Gen. This is the heart of how this whole process works, and this is what saves you probably hundreds of hours or days for the project. Because typically what you see is somebody goes in and they do a replicate to do a baseline to see how long the copy process is going to take. Say you're running 100 petabytes of storage you want to copy. You need to get a baseline of what performance impact's going to be and how that process is going to play out and how long it takes. The LTD Gen will generate all of that information for you. It provides source and target. And again, I'll show you in detail how that works. But these two are the most critical steps. Anything downstream is a result of the source and target pairings that's been identified with the discovery in the LTD Gen process. And again, I'll show you specifically how that works. Once you have verified that your Gen and your discovery process is complete, and that's what you expect for the migration, the Gen job will automatically generate your migration JCL for you. It will generate a member called Alex SCOM, which is your Syscom allocation. You need a Syscom for every session that you run. Typically, we've seen in the past that people want to run 400 to 500 volumes per session. We have successfully tested 15,000 volumes per session. So there's a lot of flexibility and a lot of automation that will build this environment for you in a matter of minutes. We have a member called GenCat that basically just generates catalog entries for you, catalog commands for you, if you want to use these working data sets on a system that you did not initially allocate them to. So say you're going to a standalone or a floor type system to do a migration of some volumes, we can issue the catalog commands for you so you do not have to update all of your JCL manually with the volume equals SEER equals specification. We also generate the fallback. This is JCL needed to fall back to the original source volumes if for whatever reason you decide that you don't want to continue with the configuration or the migration, or the migration failed on a number of volumes that are unique or specific to an application that you may want to fall back. This is a time where it's very pressure related. You don't want to be trying to generate back out JCL when you just had a failure. So we do that for you ahead of time in case that situation arises. There's a member called vol set A. That is a listing of all of the volumes for this migration. So you can go in and quickly see that you have a number of volumes, how much capacity is associated with it, and how much data needs to be migrated. Meaning, if you choose the option of fast copy, then it only copies what's allocated or what's used, not or what's allocated, not available capacity wise. It builds all of your agent jobs. Again, your agent jobs are jobs that run on systems not doing the copy, but that have access to your data that you're migrating. And you want to make sure that there's an agent on every LPAR, because otherwise you have a data integrity exposure. And one of the options we use is terminate, unknown terminate, unidentified terminate. We always say use the option of terminate because you never want to expose any data. We have a list member that lists all of your jobs per session. And then we have the master jobs automatically generated for you that do the actual copy. With that said, we also have members called a monitor job. This is the email alert facility if you choose to use that, and it is optional. We have the global monitor. This is how you synchronize multiple sessions at one time without having to go to each of the sessions specifically to do the migration. And then we have the reporting. So we have automated reporting that you can summarize your migration. So with that, I'm going to stop and I'm going to go to share my ZOS mainframe. Now you can see that here's how the process starts. I did mention that there was a member called LTD plan. I've copied that into my working data set here. Now this generates all of your JCL needed to support your migration. You have a high-level qualifier of the software product. This is the high-level qualifier that you installed Transverse under. You have a planned high-level qualifier. This is the high-level qualifier of the name of the data sets that will be associated for this migration. So what I did here is I put my product high-level qualifier. This is what I used when I installed it. Now, due to time constraints, I'm going to run this and show you what data sets are allocated, but I have multiple different planned high-level qualifiers that I'm going to work from. So in this case, I'm going to allocate this high-level qualifier for my plan. I want to put it on a volume that I know that's unique to me and is not part of any of your source and target pairings. And then you just make sure that your job card is appropriate for your environment. I'm going to submit this real quick just to show you the data sets that are allocated. Again, it runs very quickly. And here is the high-level qualifier. Here are the data set names that are allocated to support a migration. And you can see that they all went to my specific volume. You can also tell that the only one that has data in it is the control member. The control member is what is used to support all of your migration efforts. You can look at it real quickly. It has templates in it. And then it has 6 jobs that you run to generate your JCL. And I'll go through each of those steps here in a second. You can also see that it has a discovery DB. This is your discovery database data set. That's where the output for the discovery job is going to go. You have a gen control data set. This is where all of your JCL is automatically generated to. If you run it a second time, you will have a control.prev for previous. So it saves your previous migration jobs. We have a reports data set that gives you the reports, so we direct all of the reports to. We also direct the output of your agent jobs, your master jobs, and the volume listings. So you have a single point of reference if you have any questions about your migration. And then we have a retry.control data set. What this is if any volumes fail during the migration, it automatically generates the retry JCL. So with that said, and again, for time constraint issues, what I did is I've already allocated a demo.control. Here's the demo.control process. I made a couple updates for the templates. For the first template was the init. You need to initialize your initial target volumes. Typically, the vendor comes in, he puts new storage in there, he asks you for a prefix of the volume. In my case, I just use KT for can target, and then it's the UCB address. This builds your initialization JCL of your DASD volumes to make sure that they're clean, and it can also be used to refresh the environment or reinitialize the volume after a test to make sure that the target volumes are clean for your second test. Then you go in and run and do a discovery. This is the discovery program. It goes out and identifies all of the information that you have in your environment, and you tell it how you want to do it. It's very flexible. I'm going to go ahead and start it real quick because it runs a minute, and then I'm going to discuss it while it's running. You can do the include by source unit. So you can do a unit. You can do it by source control unit. So you can do it by the whole control unit. So if a vendor comes in with another storage unit, you can put the serial number of that unit and include that as source and target. You can use vol.ser, and you can also use storage group. So there's many different ways. It's very flexible. You can also use capacity. So if you want to go from a smaller to a larger capacity, you can include and exclude based on capacity. So what I'm going to do here is when I submitted it, I'm going to show a migration of just 16 volumes. I'm going to go from 4FEZ0 to 4FEZF as my source volumes, and I want to go to a target volume of AbleF-EZ0 to AbleF-EZ-Fox. So that runs. Let's see if the job is still running here. It usually takes about 2 minutes, and it just finished. So when it finished, what you do is you go in and refresh your data sets. Your discovery database will have the information for that sysplex. In my case, it's called TDMF Plex. That's the name of the Plex that I run on. You can browse it. It tells you that in this Plex, you have 4 different systems. This is the ZOS level for the system. And then it has a list of all of the volumes for this environment. And again, this is a test environment, but we have over 40-some thousand volumes in here. So I went through and did a discovery of those 40-some thousand volumes. And now what you want to do is you want to go ahead and run what's called the gen init. This will take that information that you just did and build your init commands. But before I get to that, let me go back and show you one more thing, that this is the validation process you need. You need to make sure that this process is correct. So I would do a find on S for 75, means find sources. This is the indicator of source and target. So you need to make sure that in this case, all of the data, all of the volumes that have an identifier of source are the ones that you want to migrate. And then you can also do a find for the target, F space T75. Again, you want to make sure that these are your target volumes, because anything generated downstream is going to be generated based on these 2 indicators here. Either it's a source volume or target volume. So if it does not have an S for source or a T for target, it's not going to be part of the generation process. And again, in my case, I know I've got 15. I just do a quick find S75 all, and it tells me that I've got 16 volumes. That way you just double check and make sure the process is correct before you move on to the gen. Then you go in and do the gen init. What this does is it just builds your init commands. So I'll submit that. It runs real quick. And again, this can be done. This is a simple case with 16 volumes. I've done this with test cases of 5 to 10,000 volumes, and it runs very quick. What that does is it generates your init commands. You go into your gen JCL and you look at the bottom, and it's got your target inits. This initial stuff will not be there because I've run this before, but we'll go over that in a second. But this is your target init. Basically, you build your init commands for all of your target volumes. So you run this before you start the migration. If you're using a migrate, or if you're using a replicate, which is a point-in-time copy, and you're just using it to get a baseline, then you would reinitialize the volumes after the replicate migration completed. If you're doing an actual migration and using the migrate, which does the volume swap automatically, then you would have to use the fallback facility, or you would use a different init deck that would either erase or re-init your initial source volumes. It has your very offline commands. Again, it's just a very offline. Yeah, the volumes have to be offline to be initialized. And then it has your very online commands where your volume has to be online. Now, the next process you go through, which I'm not going to do because I've already completed it, is you would do the very off to make sure the target volumes are offline. You would run the init. The init only takes that data that we just provided or just generated and does your init. Then you would do your very online command. And that basically just takes and varies the volumes back online. So that's an initial setup type process. Now you're ready to do your generation. And this is where the game changer, in my opinion, comes into play, is because there's a lot of moving parts to do a data migration. You have, like say, communication data sets, you've got agent jobs that have to run on every LPAR, you have master jobs, you have different options and parameters needed. What this does is does that automatically for you. Again, it starts with the product high-level qualifier. This is the high-level qualifier for your product. And this is your plan high-level qualifier. This is where all of my data sets are going to go to. The LTD plan will generate those data sets for you. The plan vol, again, I'm going to make sure all of this data goes to a specific volume. In this case, I'm going to do a replicate. You have two options. Again, you have the replicate option, which is a point-in-time copy. And you have a migrate option, which is an actual volume swap from source to target. You have mapping rules. We have mapping rules of explicit or auto. Explicit means I know what my source and target pairings are going to be. They've been identified in the discovery database, but I want to specifically specify what they are. If you just want to use the source and target pairings that's in the discovery database, you can use auto and it will do it automatically for you. You can allow small to large migrations. A lot of companies are going from mod 3s to mod 54s or to EAV volumes. That's an option. In this case, I'm not doing it. You have special migration and duplicate migration. These are volumes that fall into different categories. A special migration are volumes like your IPL volume, your coupling facility volume, your catalog volumes. You want to make sure that they are built specifically to that environment and only run single volumes at a time, not run hundreds or multiple volumes at one time. And then you have a duplicate migration, which identifies the volumes that have the same vol SEER but are on different UCB addresses. And again, the list only for this case is just list them, do not generate the agent and master jobs for you. You have the options for online or offline. So that, again, it's very flexible. Then the syscom volumes, these are the volumes that you want to allocate your syscom data sets to. Your syscom prefix, this is the prefix you want to name your syscom data sets. And then you get to source volumes and target volumes. Again, my source volumes are included unit 4F-EZ0 or 4F-EZ asterisk, means I want those 16 volumes. My target volumes are able-F-EZ asterisk. Now, you have source and target DD. This is if you do specific or explicit migration, meaning I want to go from 4F-EZ to able-F-EZ. And then this is just a comment so I can see when the jobs are generated, what pattern was picked up for this migration effort. And then you have your Plex information. This is in my case, it was a TDMF Plex. I use an ID of TDM. That's just the first three characters of the Plex I'm running from, because a lot of times you could do a migration with multiple sysplexes and you want to generate the jobs specifically to that sysplex. And in this case, I'm going to do a volume limit of 4, meaning I only want 4 volumes per session. I'm going to submit this, and this is going to do in a matter of minutes what typically takes hours or days to do. It will automatically generate the JCL that you need to run a migration. Go real quick to the job. Okay, it finished. Now that completed and did all of the prep work needed to do a migration. You go in to to refresh your data. Again, you see a gen.control. This is what I just generated. And you see a control.previous. That's what was there before. if you've done, multiple test migrations. In most cases, people do replicate to get a point in time and get a baseline for how the process is going to work. Now, what has been generated for you is first the allocator of the syscoms. So the first step you need to do is you need to make sure that you have syscom data sets available for your migration. So I'm going to run this and allocate my syscom data sets. So now I've got my data sets, my syscom data sets allocated. The next thing I need to do is I'm going to start my global monitor. Now since I have 4 sessions running, I have 4 syscom data sets. I'm going to start this global monitor, and this allows me to synchronize my whole environment at one time. You need to make sure you run this on the system that you're working from, because the way it works is that a master session has to be replied to on the system or LPAR that it's running on. And in this case, I'm going to have master sessions running on 4 different LPARs. So I submit this, I start the global monitor. Now I can generate my catalog entry and I can generate my email notification. This again is if you have it available. We do have XMIT IP available. So I'm going to do a real quick email notification setup. I'm going to do the intervals at 5 minutes, and hopefully we won't run out of time to do this. And I'm going to start that process. So on the intervals of 5 minutes, it's going to submit jobs for me. Nope. I did not capitalize the L there, so let me do that. Now that will work. Okay, so now I have my monitors running. Now this is the volume set. This is the list of all of the volumes we're going to migrate. Again, it's replicate, point in time. I've got 16 volumes. I've got 50,000 cylinders, and the volumes are empty because this is just a test. Now, what you have is you have your agent jobs. These are your agent jobs needed for every session. Again, in this case, I've got the agent job for TDM-A, TDM, and TDM2. So I've got 3. You have 1 master and 3 agents for every job. You have the list data sets. These are the volume listings per session. And again, you can see that it took that comment that I had. So I know I got this source and target pairing from this pattern. Again, that's for each of the jobs. You have master jobs and you have scan jobs. What you want to do is you want to run a scan first. A scan basically validates that your source and volume pairings are correct. They're online, they're available to copy, and all of the parameters that you have specified are correct. So I'll take a quick look at this. The only difference between the SCN and the MST jobs is that it has PARM master scan. The master jobs just do not have the scan. And again, this has your information that we're talking about, your actual parameters you're using. This is the master job. These are the 3 agent jobs. And again, that one parameter I told you about unidentified systems, always specify T here for terminate. You never want to run a migration with a system that has access to a volume you're moving data from that you're not aware of. This makes sure that any updates are caught and there's no data integrity exposure. So what I typically do is I run a quick scan on one just to make sure it works first. You have to submit the agents for that scan. And I'm going to go real quick. I'll probably miss it to the monitor to see if I catch it. I did catch it, and it terminated. So now that means that it went that quick, and you would go into your output, identify the data set or the jobs, and take a quick look at it. If there's any errors, there will be an LTDE report DD here. In this case, it's not. I just do a quick find on scan. To make sure it's scanned, I know I have a scan here. So with that, I know that I've got the scans working. Now I want to make sure that all 4 of them work. So I'm going to just submit all 4 of the scans. And then I'm going to submit all 4 of the agents. Now this is what my environment's going to look like, and this is how it's going to work when I actually do the migration. I'm going to try to go back. I'm probably going to miss it again because it runs real quick. Nope, I didn't. It's doing the activate and it does the terminate real quick. So basically what that did was it validated that everything that I generated automatically is correct and is valid for a migration. So now I'm going to actually do the migration. I'm going to go in and run the master jobs. Again, the master jobs use the same template. The only difference is as parm equals master instead of the scan. So I'm going to go ahead and actually do a migration here of these 16 volumes. So I'm going to submit the master jobs. And then I'm going to submit the agent jobs. Now I'm going to go back to your monitor. Now we're going to watch, and it's going to it's going to do the initial, handshake, and it's going to start the copy process. As you can see, it's doing the copy process now. During this process, you can hit F6 and it compresses what you have here. And you can see that they're in copy mode. We're going to wait for everything to go through and do into refresh mode. So once it finishes, everything will go into refresh mode. And that's where you have to identify and know that the process for the synchronization is needed. So I'm going to quickly go to that global monitor. What we have running is the global monitor. We can look at it real quickly to see that it has processed all of the 4 syscom data sets and is participating. So meaning it's looking at all of these sessions to make sure that they're ready and running. You go back to, I can actually go back, see where I'm in refresh mode, and you're going to notice that once it is ready, on the master system, again, this is the master system, you're going to see of sync volume needed message in the corner. This means that I've got everything I need for this session ready to synchronize. Now, you would have to go to each of the systems, and at this point, you would have to put a prompt group here. I got a lot of emails coming. A prompt group here that would, for every session on every LPAR. Now, instead of doing that, what we have available is the global monitor. So we're going to go into the global monitor. At the bottom, it's going to say synchronous is ready. So what I need to do now is I just need to modify at GBL TDM, sync. Now what this is going to do is it's going to synchronize all 4 sessions. And it says synchronization readiness has been achieved. You can go to your monitor. You can see where it's terminated, complete. It does a refresh. Then it terminates and completes your job. So this will synchronize all of your sessions concurrently. Go back. It tells you that the 1 system is left. It will go through and synchronize the other, once it does the handshake, to the other 3. And then it will leave, meaning so it's gone in and did the automatic synchronization to every session. Now the migration is complete. So what I want to go through now is I want to look at one of the master jobs. Make sure that everything worked as planned. So just do a quick check of the master job. You get a condition code of 0. You go to the volume check, and you can see that this session had 4 volumes. The migration was complete. There were no mismatched volumes. So now, as a follow-up, you want to do a report. So I'm going to go back into my generated JCL, and I'm going to run a summary report. This summary report builds the report you needed to support your migration. I'm going to run it real quick. It only takes a second. It scans the job output and builds a summary report. The reports are in your report data set. Do a quick on that. A combine shows that I've got 4 master jobs. They all ran. These are where the master jobs were. And it gives you a volume list at the bottom. The bottom basically tells you that, in this case, I have a volume summary. All of them completed successfully. So at that point, you have completed your migration, and you have all of your JCL reports needed to support that function. So with that, that's and then I'll show you real quick how the email notifications happen. This is a sample. Let me get my cursor there, and shows you that here's the migration that you had. You had 16 volumes in each session here.
I hope you guys have really taken a lot from this webinar. I want to thank Ken again for just really taking the time to sort of bring this product and this solution to life for us over the past 45 minutes. He has a wealth of knowledge regarding Transverse, and he's just super willing to share this knowledge with all of us. So thank you, Ken, again. And again, my name is Alex Miller. I'm one of the team members here at 21CS for direct sales for ZOS. I do hope that today's webinar has been fruitful for all of you. If there's any questions you have, my contact information should be on the first slide. If not, it's alexandra.miller@21cs.com. Please feel free to reach out. Or if you have any ideas or questions, feel free to reach out and ask that as well. Our goal is to share these solutions and truly make your workflow easier and more effective. So please don't hesitate to reach out. And thanks again to all of you, and have a fantastic Wednesday, everyone. Thanks again. Bye.